Hey guys, in this video I'll be answering the Maths Method Sample Exam 1 question 10. Reading the question, we've got the line containing the points M and N intersects the x-axis at the point M with coordinates 6, 0. The line is also a tangent to the graph of y equals ax squared plus bx at the point Q with coordinates 2, 4, as shown below. If a and b are non-zero real numbers, find the values of a and b. To work out the values of a and b, we need to use two pieces of information from the graph to set up two equations in terms of a and b and then solve simultaneously. The first information we can use is the coordinates of the point Q, which is 2, 4. This means when x is equal to 2, y is going to equal to 4. And so subbing this into the rule of y, we're going to get 4 is equal to a times 2 squared, which is 4a, plus b times 2, which is 2b. We can divide both sides by 2, and so this is equivalent to 2 is equal to 2a plus b. And so this is going to be our first equation. The second information we have is the tangent line at the point Q. Given that we have the coordinates of M and Q, we can work out the gradient of this tangent line, which is also going to be the gradient of the curve y when x is equal to 2. And so if we let this be x1 and y1, and this x2 and y2, then we can work out the gradient of this tangent line using the rule y2 minus y1 over x2 minus x1. And so the gradient of this line is going to be 0 minus 4 over 6 minus 2, which is going to be minus 4 over 4, which is equal to minus 1. And so the gradient of this tangent line is going to be minus 1, which means that the gradient of the curve when x is equal to 2 is going to equal minus 1. And so from here, what we need to do is derive y to get y dash, and so y dash is going to be 2ax plus b. And so we can say that when x is equal to 2, the derivative y dash is going to equal minus 1. And so subbing this into the rule of y dash, we're going to get minus 1 is equal to 2a times 2, which is going to be 4a, and then plus b. And so this is going to be our second equation in terms of a and b. From here, we can use the method of substitution to solve for a and b. And so looking at the first equation, rearranging this, we can make b the subject. And so b is going to equal 2 minus 2a. Subbing this into the second rule, we're going to get minus 1 is equal to 4a plus 2 minus 2a, which is simplified to minus 1 is equal to 2a plus 2. Solving for a, this is going to be minus 3 is equal to 2a, and so a is going to equal minus 3 on 2. And now that we have the value of a, we can sub this into either equation 1 or 2 to solve for b. Subbing into the first equation, we're going to get 2 is equal to 2 times minus 3 on 2 plus b. This is going to be 2 is equal to minus 3 plus b, and so solving for b, b is going to be 2 plus 3, which is equal to 5. The line containing the points u and v intersects the coordinate axes at the points u and v with coordinates u0 and 0v respectively, where u and v are positive real numbers and u is between 5 on 2 and 6 as shown below. The rectangle OPQR has a vertex at q on the line. The coordinates of q are 2, 4 as shown below. Find an expression for v in terms of u. Looking at the diagram, the points v, q and u lie on the same line. This means that the line segment VU is going to have the same gradient as the line segment QU. Using the gradient formula, we can work out and equate the gradients of these two line segments. And so if we let this point be x1 and y1, and this point be x2 and y2, then the gradient of the line segment VU is going to be y2 minus y1, and so this will be 0 minus v, which will be minus v over x2 minus x1, and so this is going to be u minus 0, which is just going to be u. And for the point Q, if we let this be x1 and y1, then we can say that the gradient of the line segment QU is going to be y2 minus y1, and so this will be 0 minus 4, which is going to be minus 4 over x2 minus x1, and so this is going to be u minus 2. And so from here we can say that the gradient of the line segment VU is going to equal to the gradient of the line segment QU. And so this is going to be minus V over U is equal to minus 4 over U minus 2. We now have an equation in terms of v and u, and we have to solve for v. The two negatives will cancel out, and so we're going to get v over u is equal to 4 over u minus 2. Multiplying both sides by u, we're going to get v is equal to 4 times u over u minus 2. Find the minimum total shaded area and the value of u for which the area is a minimum. To find the total minimum area of the shaded region, the first thing we need to do is write down a rule for this area in terms of u. The area of the shaded region can be found by the area of the triangle minus the area of the rectangle OPQR. The area of the rectangle is going to be 2 times 4, which is 8 square units. And so we can write the area of the shaded region as a half times base times height, which is the area of the triangle, minus the area of the rectangle, which we know is 8 square units. The base of the triangle is u units, and the height of the triangle is v units. And so this is going to be a half times u times v minus 8. From the previous part of this question, we worked out v in terms of u, and so subbing this in, this is the same as a half times u times 4u over u minus 2, and then minus 8. The 4 and the 2 will cancel out, and so we can write the area in terms of u as 2u squared over u minus 2 minus 8. To find the minimum area, what we need to do is derive a using the quotient rule, let it equal 0, and then solve for u. And so deriving a, we're going to get the bottom function, which is u minus 2, times the derivative of the top function, which is going to be 4u, minus the top function, which is 2u squared, times the derivative of the bottom function, which is going to be 1. And this is going to be all over the bottom function squared, and so this will be u minus 2 all squared. And the minus 8 will derive to become 0. Simplifying this, this is going to be 4u squared minus 8u minus 2u squared all over u minus 2 squared. And now collecting like terms, this is going to be 2u squared minus 8u over u minus 2 all squared. And so if we let a dash of u equal 0 to find the minimum, then this means that 2u squared minus 8u is going to equal 0. Solving for u, we can take out 2u as a common factor, and so this will be 2u times u minus 4 is equal to 0, which means then either u is equal to 0 or u is equal to 4. We're told that the value of u is between 5 and 2 and 6, and so therefore the value of u must equal to 4. And so when u is equal to 4, we're going to get the minimum area. To work out this area, we need to evaluate a of 4. And so subbing 4 into the rule of the area, we're going to get 2 times 4 squared, which is 2 times 16, divided by 4 minus 2, which is 2, and then minus 8. The 2's will cancel out, and so we're left with 16 minus 8, and so this is going to be 8 square units. Find the maximum total shaded area and the value of u for which the area is a maximum. We just worked out that the minimum area will happen when u is equal to 4. And we know that the value of u must be between 5 and 2 and 6. This means that the maximum area will occur at one of the endpoints, either when u is equal to 5 and 2 or when u is equal to 6. Note that we're not asked to find the local maximum, and so we don't need to find the derivative here. We're asked to find the maximum value of the function a, where a is equal to the area of the shaded region. To understand this graphically, we know that the value of u is going to be between 5 and 2 and 6, and the minimum is going to happen when u is equal to 4. And so the graph of a could look something like this. And what we're looking for is which endpoint is going to give us the maximum value of a. To work this out, what we need to do is evaluate a of 5 on 2 and a of 6. We know that the area is equal to 2u squared over u minus 2 and then minus 8. And so evaluating a of 5 on 2, this is going to be 2 times 5 on 2 squared, which is 25 on 4, over 5 on 2 minus 2 and then minus 8. Simplifying this, these two will cancel out and we're going to get a 2 at the bottom, and so this is going to be 25 on 2. Divide by 5 on 2 is 2.5, minus 2, we're going to get a half, and then minus 8. These two will cancel out, and so we're going to get 25 minus 8, and so this is going to be 17 square units. And now we're evaluating a of 6. This is going to be 2 times 6 squared, which is 2 times 36, divided by 6 minus 2, which is going to be 4, and then minus 8. This will cancel out with this, and this will be a 9, and so we're going to get 18 minus 8, which is equal to 10 square units. And so therefore, we can say that the maximum area is going to be 17 square units, and this will happen when u is equal to 5 on 2. Which brings us to the end of this question. I hope you found this video helpful, and if you did, give it a thumbs up. And if you guys want to learn how to answer exam style questions related to minimum and maximum problems, then log into the Maths Methods Club. And from the main topics, select differentiation. And then from the subtopics, select maximum and minimum values. Here, you're going to find all the exam questions related to finding the minimum and the maximum values. If you want to try Tech Free questions, go to question type and select Tech Free. Try out these questions and see how you go. Good luck, and I'll see you guys in the next video.